How'd we do? When we are sketching y equals e to the x, make sure you have your asymptote, your 0.01, and your handy dandy curve just like that. This guy is called the exponential, right? There he is. Oh, this was your easy one. Hopefully you got this one right. That's a PE from the origin. And this is your square root function, which has an initial point at the origin, and it goes up and out. Make sure it looks like that on the paper, okay? Make sure it's going up and out like that. We good there? All right, now what do we got? Now we want the name of the indicated function. So what do you think that first one is? Logistic. Please don't abbreviate that. It's logistic. I'm afraid if you abbreviate it, it will look like log, and we already have a log function too, so we're not going to abbreviate this for right now. How about the next one, B? Which one's that? That's your greatest integer, yeah. And how about that last one? Squaring. Or sometimes we call it the quadratic. Either one is fine. You know that quadratic functions are x squared. So you call them either one. Don't need both. Either one's fine. Okay with that? Everyone? All right, now we've got to write the equation. So these are going to be y equals. So what did you decide for that first one, which is the linear or identity? Y equals x. That's the easiest one of all. What about the next one? Has an asymptote. It comes up and out. That's your natural logarithm, so ln x. If you put log x, I would be okay with that, because that shape is the same for any logarithm. So ln x is fine, log x is fine as well. If you remember in your mind, oh, that's the logarithm function, then log x. All right, and what about c? Be careful, what's c? That's cosine. COS x. How do we know it's cosine? Because it doesn't go through the origin. It starts up here at the top. All right, now here comes the hardest part. There are 12 BFFs that we went through the other day. 9 of them are already on board. You're going to have to know them well enough to decide which ones are missing. And you can either write the equation, draw the picture, or give a name. I don't care how you list it. Any way you can think of it. So, can you think I can think of one that's missing. Sine is missing, right? So I can think of that one. So okay, y equals sine x is missing. You said reciprocal. And cubing. There we go. You got it. There are the 3 that are missing. And I wrote an equation in 2 names, because that's what you told me. That you could write the equation, you could draw the picture, whatever you can think of for those last 3. Okay? Well, if that wasn't enough excitement, turn it over. Yeah, and there's another one. All right, so there you go. Give it a shot. See how much you can do without your notes. That will give you an idea how much you need to prepare.
Always gets so lucky where she never sees it. So good. And Bryce Hunter was not a good one.
Bryce made that throw.
You know, I saw throwing the ball for
Let's gonna sit there.
Right. Well, what is when he beats you before this? What is when he beats you before this?
Alright, friends, how we doing? What is number one graph? What is it? What is it? This is your friend, the logistic. So you have an asymptote at 0, you have an asymptote at 1, and then you have a little squiggly that looks just like that. Okay? This one we've already talked about today. Starts up here. Is that what you sketched? Something that looks like that, I hope?
Yep.
Alright. Forever and ever. So does this build? Alright, this guy, I hope you put an asymptote on each axis. And then quadrant 1 and quadrant 2. Which one is that, by the way? That is your reciprocal function. That's your reciprocal function. Okay, then what? Oh shoot, I just put my paper away. I put it back in the recycle. So, write the name of the indicated functions. What do we got number 1? Linear or identity. Either one is right. Doesn't matter, linear or identity. Then what do we got?
Let's get the greatest answer.
And then we have to do Alright, then number 3, we're going to write the equations. So these are all going to be y equals.
No, it's just that right.
L and X. Y equals log X.
Or L and X.
Log X or ln X, either one. I'm writing down 2 for some of these. You don't have to.
Okay.
1 is enough for all of them. then you've got
Absolute value equals.
absolute value,
X cubed.
and then you have x cubed. Alright, and we've got the hard one, so 9 of them are up here. Quadratic is not up there.
Side.
Quadratic.
Thanks, Miss.
Quadratic is also known as
Squaring.
squaring, so if you wrote that, that's fine. You said sine.
Exponential.
Thanks.
Later. Oh, we did Mr. Bean's class.
Tomorrow, we have a quiz. It will look just like this. Okay? I'm gonna sneak a couple bonus questions on there too,
About what?
whatever I wanna make them about. Okay? But basically, what you're required to do will look just like this. Got it? Okay, let's get our notes back out and let's finish up what we started the other day. We will be having another quiz more in-depth stuff, but first let's finish up our 150 notes.
Finishing up on a project.
Alright, so now we are on the back of page 15. Back of page 15. Brian, can you stay up for me? So on the back of page. Alright, number 26. You're to name the 3 functions with this end behavior. Now remember, this notation means that as you go to the left, this is negative infinity, your curve is going down. So can you name 3 functions that behave that way? They have an arrow going down right there. Okay? Now be careful. Quadratic, the quadratic actually looks like this. So its arrow on the left isn't going down, it's going up, right? Linear or identity, that would be one of them. You have to be careful about the reciprocal. The reciprocal function looks like this. So as we go to the left, is that arrow shooting down? No, it's actually getting closer to 0, right? So that's not cubing is 1. Think about what cubing looks like. Doesn't cubing look like this? And that looks like identity exactly. Is there another one that just keeps marching down?
Natural logging. Logistic, maybe?
Absolute value.
No.
Okay, and let's look at logistic. This is the logistic function. As it goes to the left, is it going down? Well, it's going down, but it's not going down like this. It's getting closer to 0. Is there one that just keeps marching down the page? Greatest.
I said
Oh, I didn't hear you.
Oh, that's what I
Is it just keeps going? It's getting more and more and more.
without an arrow though.
Yep. But it's getting more and more and more. It never stops. The 4 functions whose graphs look the same when turned upside down and flipped about the y-axis. Reciprocal, let's look at it. Reciprocal function. If I turn that upside down and and reflect it across the y-axis, it will be the same picture. Yep, perfect, good. So one of them's reciprocal.
Absolute value? How is that not?
Okay, absolute value turned upside down would look like this,
Yeah.
and then reflected across the x-axis, or y-axis,
right.
would still look like that.
Yeah.
And I need it to look like this. I need it to look like the original function.
Cubing?
Oh, I know.
With the cubing?
Cubing, let's look at cubing. If I turn that upside down, it would look like this. And then if I reflected it across the x-axis, would it be back to the original? Yep, so reciprocal and cubing. Can you think of another one, Finn? Identity. That's another one. Because if you turn it upside down, here's the original. Upside down would be this. Flipped across the y-axis would be back to the original.
Integer
Oh,
word?
No.
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 No. Wait,
I guess think about the open place dots on that one.
wait, so what? Oh, now we have it.
If I turn that this upside down, it would look like this. Look like it. Upside down, yeah. So it would look like this.
I think sine
And then if I flip it across the y-axis,
Sine and all
it won't work because the dots are going that way. All right, there's one more, guys. Let's see. Linear and cubing, okay. What am I missing? Log.
No.
What about exponential?
Turn it upside down.
Exponential.
Look like that. And then no, that won't work.
This way? No.
Did we say the logistic
This
one?
way.
Logistic.
Now. Or you have to put exponential.
I'm gonna use.
If I turn it upside down, no, that
I think
logistic
it's
won't work.
this piece.
Exponential.
Exponential.
So.
No, it's gonna be underneath there.
Ah, wait, flip it and then. Oh, you gotta go with the X first and then. No, that would not work actually.
What happens with sine?
Oh, Brandon, yeah, we call it sine.
It's sine.
Brandon told us no.
Upside down. And then fold it this way, won't it work?
Brandon told us counts.
Like you said.
No, he said sine, and you were like, no.
Alright, one more. Only two. The two functions whose graphs are identical except for a horizontal shift.
Whatever that means.
Sine and cosine. If you took sine and shifted it a little bit, one way or the other, wouldn't it look just like a cosine? Or vice versa? They are the same exact curve, just shifted a little bit.
Ball.
All right, number 3. First, we're going to sketch these by hand, then we're going to sketch them on our calculator and see how it came out. Okay? So no calculator yet. We're going to get those out in a second. But first, we're going to see what we can remember about sketching this by hand. What shape? Parabola. Sitting where? Down 5.
No.
Down 5.
It's not within the.
So there it is. All right, get out your calculator, type in that equation, zoom 6, so you have a standard window, and see if that is indeed the picture that you got.
That was a
Everything has the calculator out, Mike.
zoom in 6.
Zoom 6, hit zoom 6. in the system screen,
Yeah.
and you should see that parabola, right? Perfect, beautiful. Why do I not see a calculator on you guys?
Come on, Roy.
Come on, guys, you shouldn't need a personal invitation. All right, next one, by hand. I'd like to,
Yeah, are we supposed to be finding the domain already?
oh, is that what it says?
Yeah.
Oh, sorry, thank you, we are. So for this one, though, it's easy. Domain is
All reals.
all reals, so negative infinity to infinity. And range is
-5.
from -5 to infinity.
Yes.
Yeah.
Yes, it is right.
Because there's a point right here.
Solid point, bro.
Now, before I graph the next one by hand, I'm gonna remind myself what the normal logarithm looks like. This is the normal. Would you agree with that?
Yeah.
Asymptote at 0, intersect at 1, up and out like that. Now, what has happened? Okay, which means what? 6 left. So that means what was at 0, which was an asymptote, is now at -6. And the point, the asymptote, oh yeah, the asymptote was 0. The point is gonna be at -5 because it was at 1. And that's what it looks like. Alright, let's graph it on our calculator, just type in that equation.
Just make sure that, wait, so we're allowed to use the calculator, we're just practicing getting it before using your calculator?
Right.
So
It's
the
not have to be done by hand, it's easy.
where's the L in
And
there?
that line starts right high.
No. The line, it's all the way down here, it starts right next
It's
to
on the
-6.
negative, it's the
It
5.
goes through the point.
Why can't you just graph it right into? You just do 6.
Oh, and
Your window, your graph.
just leave it here.
What is going on?
Okay, did you get it?
What is zoom 6 doing?
Three six
Resets your-
squares is 3. So it's -10 to 10. Instead of -200.
How come it just starts?
It doesn't start there. What, Michael says, how come, mine doesn't, I don't even see this part down here. Mine looks like it starts like right there.
Yeah, that's where mine is.
Okay, why is that? Because the calculator
Oh, the asymptote?
doesn't show the asymptote, right? It is indeed going all the way down, you're just not seeing it because it's so close to that asymptote, it's just disappeared.
So is that like a good reminder that those type of ones?
Oh, yeah, a logarithm's always gonna have an asymptote in it. So, we know what the picture looks like. So our calculator is deficient in this regard, and we just have to be smarter than it and know there's an asymptote there, right? The logarithm isn't gonna start right there, it's gonna keep going forever and ever. All right, let's see. Oh, yeah, thank you. I keep
This is
forgetting.
all real.
Domain, watch it, the domain is not all reals for this guy. The domain is -6 to infinity. And notice that -6 is not bracketed
It's not a point.
because it's an
Oh, yeah.
asymptote. Yes, I can open circle, yeah.
Range is all real.
And the range is indeed all reals, very real. Because this thing's going all the way down and all the way up. All right. What does 1/x look like? That's got an asymptote.
Asymptote.
Top right, bottom left.
Now, what are we doing? in this
Bring it
case.
up back. Up to
We're
three.
gonna add 3. So, up 3?
Up 3.
Now, up 3 will have no impact on the vertical asymptote. So the vertical asymptote is staying right here. But up 3 will change your horizontal asymptote, won't it?
Yes, it
Now it's gonna be at 3.
Would it be X equals 3 or 1?
Y equals whatever axis it crosses is what it is. So a horizontal line is gonna cross the Y axis, so it's Y equals 3. And then you have the same shape you had before, you have to change the shape. Go ahead and graph it on the calculator, but remember, you won't see the asymptotes. You should see both pieces, but you're not going to see those asymptotes.
So you're just going
Does it get something that looks like that? Exactly like that. All right, domain and range. Now be careful. Does this go all the way to the right and the left? It does, but it gets split. So we're gonna have to go negative infinity to 0, and then 0 to infinity. That is our domain. X is everything except 0. And range is everything except actually positive 3. So your range is negative infinity to 3, and then 3 to infinity. Okay? All right. Try D. What's this one gonna look like?
Right
It'll look like a V. And move where? So if I'm graphing it by hand, that's where I graph. That is exactly what I should see on my calculator. Is it? Absolute value is in math
number.
It's right there. What's your domain, bro?
Negative infinity, positive
What's your range?
0 to positive infinity, or oh no, 0.
All right, now, this next one,
I can't do that.
this next one involves a transformation that we haven't talked about yet. So let's review what the greatest integer normally looks like. Solid dot at the origin, over 1, color over 1, and then put an open dot. And then up 1, solid dot, over 1, open dot. Okay, does everybody remember that? So the thing about the greatest integer, the normal basic greatest integer, the thing about it is the steps are 1 unit long, and 1 unit apart. So it's over 1, up 1, over 1, up 1. That's how it looks. This is not a plus or a minus. If it had been a plus or a minus, it takes your exact same shape and puts it somewhere else, right? Neutral. When it's a divider, a times or divide, then it actually changes the shape. It stretches it or shrinks it. All right? Does anyone have a wild guess, recognizing that that is inside the parentheses? Does anyone have a wild guess what's going on with these steps? Ben? They're twice as long. That's exactly right. They're twice as long. And before you look at me and say, wait, Ben's a genius. How did he know that? Remember, when it's inside, it's the opposite of what it looks like. So when it says x minus 4, it's actually right 4. So when it says x divided by 2, it's actually times 2. So your step, you're still starting at the origin, but now you're going to come over 2. And then you're going to go up 1. That part's not changing. The vertical's not changing. And then over 2. So this is what it would look like by hand. All right, now let's do it on our calculator. So remember where you got absolute value? You're going to get INT in the same column as stuff. So you're going to type in y equals INT, x over 2, and hit graph. Now, again, the calculator is deficient in some ways.
Look at that, that's sick.
Oh, that's
Let me see here.
That's sick.
I don't know if the new calculators, yeah.
That's
Okay.
savage.
So the new calculators, look what mine does. I have an old calculator, so it connects them. It literally connects them. You guys with the newer calculators, you physically see the steps. And see how they're twice as long?
They're literally, I don't know.
They are.
Yeah. You have an old one, so it just.
That's probably not the domain.
So like.
All right, domain.
The new ones.
They're both old.
Well, be careful. The domain is all real, that's for sure. But tell me about the y values. All of these y values are -1. And all of these are 0. And all of these are 1. Your domain isn't all real numbers. You don't have 1/2. You only have the integers. So you have -2, -1, 0, 1, 2, dot, dot, dot. So that is your range. Your range is only the integers. There are no fractional y's. It is called the integer function. They are integers.
So what would be asked range on a great signature function?
You could be.
Tomorrow?
No. Tomorrow is only.
Yeah, that's what I
basic
thought, that's what I
basics. Tomorrow is only basics. Name, graph, equations. All right, we have 3 more problems to do. We're probably not gonna get them done. But you could certainly start on your 1.3 homework. I'll assign it tomorrow, so it'll be Thursday. Unless by some miracle we get all these done.
Whoa.
I accidentally.
That's a clock.
Yeah.
All right.
Right, wake up.
Anyone know what this is called? A piecewise
piecewise function.
And they are called piecewise because we graph them in pieces. You have done these before. My strategy is a little bit different than others sometimes. I'm going to do it my strategy, you do it your strategy. As long as our pictures match, all is well. Okay? Here's how I do it. When I look at this, I can see that the issue is happening at 0. So I'm going to put a squiggly line. It's not an asymptote. It literally is the place where the picture is broken into pieces. Right there. Then I'm going to take my trusty red marker and I'm going to graph that. Y equals X. That's linear with no adjustments. It's just a basic linear function. So I'm going to go ahead and graph the basic linear function. And I'm going to notice that it hits the squiggly line or the crack in the picture. It hits right there. And because of that, it's going to be a nice solid dot. So where it hits the crack in the picture, the break in the picture, it's going to be a nice solid dot. Now, my line is in 2 pieces. Would you agree?
Yes.
This piece and this piece. This tells me which piece to keep. Since that says less than or equal to 0, I'm going to keep the left and erase the right side of the picture. Now, you do everything in pencil, so that's easy. Just erase it. Okay, good. Now, this is all that you have left.
Why do you erase that?
Because this says X has to be less than 0. And that's the left side of the picture. So for the top piece, it's only the left side that matters. Alright? Now, with my brown marker, I'm going to do that one. What is that? And it's just a standard normal parabola. So here we go. And it hits the crack in the same place, doesn't it?
Yeah.
So I'm going to go ahead and put a circle there. Now, under other circumstances, that circle would be open. Open. But it is open brown, but it's already been colored in red, right? But I'm not going to make it brown, it's just red.
How would you be able to tell, like,
It's a continuous function, so it's open. Now, which piece am I keeping? I've got a left side and a right side of my parabola. I'm going to keep the right side, so I will erase this, and there it is. There is my
That's-
piecewise function.
That's the problem. Bless you. Bless you yourself.
All right, here we go. My break is again at 0. All right. What's my red function? What's that guy? That's the reciprocal. The reciprocal has an asymptote right on the break. There's an asymptote here. And looks like this. And that would be my picture, except for what? I'm only supposed to keep the left side. So this part's gone. And that's what I got. Notice it never hit the break, so I don't have a circle on there. No dots. What's this guy? Square root. So he starts at the origin and shoots up and out. And that's going to be a closed-in dot. We're very much friends.
Thought we weren't gonna get it done.
Yeah, we are amazing human beings. All right, everybody okay with that one? All right, the last one. What do you notice about it? What's a little different about it?
There's 3 of them.
There's 3, which means that there are going to be 2 places where the picture is broken. The picture is going to be broken at 0 and at 1. So I'm going to go ahead and put my crack in my picture here and here. That's where my picture is broken. So there'll be a piece over here, a piece in the middle, and a piece over here. Now don't be confused, guys. This is y equals -3 minus x. What is that? That's a linear.
Inverse.
It has down here -3, right? And then a slope of
Negative x.
-1. So I'm going to go down 1, and over 1. That's 1. Down 1, over 1. So it's going to look like this. Now it does hit both cracks, but I only care about 0. So this is the only place I care about. It will be a solid dot, and I will keep
That way.
that way. So I'm going to do this one. Alright, now with my green marker, I have the equation y equals 1. What does y equals 1 look like?
Just a straight line.
Horizontal line through 1. So it's going to look like that. But I'm going to have an open circle on that crack and an open circle on that crack. See why, guys?
Yeah.
And since I'm in between, I'm going to keep the in between part and get rid of the rest of it. So I have that little thing right there. Does that make sense to everybody? All right, and then with my blue marker, I'm going to do y equals x squared, which is what? Parabola. Remember, this is the point 1, 1. So it's on that parabola. So that parabola goes right through that open dot.
So it's to the right of
It hits both of these, but I only care about this one. So right here, and that will be a closed dot. So remember when it was open with the green? Well, now it's closed with the blue, and all of this is not there. These guys always look funky. Alright, so 1.3 are actually doing one. So tomorrow, we have our little BFF 12-point checkup quiz,
Oh, wait, yeah, like.
right?
Yep.
On board, with your friends?
You can have any text or clip it next week. I'll be on retreat. Are you on first?
Here's what the beer.
Usually my Tuesday now, Tuesday after school. So we'll know by then what's happening.
Only an hour away.
When I get here Tuesday, I'm
We're starting to small.
Brandon, you're on first, right?
Yeah.